Okay, we're all set. Come on, only 12 people. We can do better. Yeah. All right. Yeah, we'll start with just 12, 13 people. It's not, yeah, there's not much theory to be asked here, just a bit of refreshing some of the knowledge from last time. So yeah, just join with the name, and you already know how to do that. Santa, hello. Yeah. Okay, one more person. Yep, 14 people. All right, I'm going to start it right now. So question 1. What does Node modules folder contain? So when you create a Node.js application, you see a folder called Node modules. So what does that folder contain? Your source code, the HTML files of your web page, the source code of imported JS libraries, or the assets of your page, like images and stuff like that. So let's see. All right, so most of the people got it right. Yeah, that's the answer. That's what Node.js contains. Good job. Next. What is a command to import a Node package to your project? So for example, if you want to import the package called Express, how would you import that project in your Node application? npm import, npm install, node add, node install. So I imagine if you started in the assignment, you should have tried this by now. npm install. Yep. So install, not import. The word import is, however, used in the code after you have imported the package. All right. Next. Question 3. How do you transform a JavaScript object to text? So JSON stringify, JSON parse, JSON to text, JSON to string. So let's say if you, for example, want to save an object to a file or to send it to someone, yeah. Everyone has answered. And yes, it is JSON stringify, JSON to string. That's not a valid function in JavaScript. So yeah, great job, I guess, answering the 3 questions of today really fast because you get points based on your speed. So yeah, good job, Andrei. Let's go next. So yeah, let's start 1 point. Yeah, let's start on the theory of today. Databases, what are those and why do we need them? So I imagine most of you heard the word database at least once in your life, I guess, at this point. But for those who don't know, a database, it's an organized collection of structured information or data. And also, yeah, typically stored electronically in a computer system. So that's pretty much it. What a database is. It's just a place where you store information. So yeah, big brain time. Some people might ask, why not just store everything in a file, right? Like that also works. You've seen that in the previous assignment. The extra part was to store your data in a static file, right, to store your objects, and that seemed to work. So why do people not really use that? So there are some reasons right here on the right side. So the data in a database has a built-in structure. So in a file, when you want to retrieve something at some point in a file, what you do, you would read all its contents. and then you go through all of it until you get to that part that you're interested in. So yeah, while once your data becomes slightly bigger, then that all of a sudden becomes quite impossible. Fault tolerant, so that's also an important part. So when, let's say, you open a file with a program, let's say Node.js, you open a file and you start editing it. If, let's say, your computer crashes or your program, throws an exception while you are writing to a file, then you might end up actually having corrupted data inside that file. While databases are fault tolerant, they are safe against this kind of operations. So if, let's say, you connect to a database and you start writing data in there, and your internet connection drops or whatever, and if your internet connection drops or something, then your data will still be saved. There'll be no corrupted entries, with some small exceptions, but that's the general idea. Ability to handle truly large data volumes. So because your data is structured, you're able to access very specific parts of your data in a very easier way. Concurrency, that's also an important word. So multiple users can use them at the same time. So most of the times, the database will not just be used by one single person or one single program. It is expected that multiple programs can connect to it, multiple clients, services. So, I mean, imagine you store all your data in an Excel file. You're only able to edit it only on your own, unless you host it on Google Drive or something, but still those files are not meant to be edited concurrently. The other thing is distributable over multiple computing systems. So that's maybe not something you'll deal with right away, but something very important is that you can actually host the database partially on multiple computers, on multiple servers. So that's usually because of multiple reasons. Imagine you have a database of, tens of terabytes. So you can't expect that you'll necessarily have all those 10 terabytes on one computer. So you'd want to distribute that in multiple places. Same with the computing power, the reading and so on. And the other thing which is very important is that why you would want to distribute a database, it's because if one of the servers crashes or dies out, you want your data to also be available in different servers. So Google would do that, Amazon, and literally any kind of database provider out there. And the last part, which is actually very, very important, is the ability to query data in very specific ways. So the word query, in case you're not familiar with it, when you speak about querying in a database, it means that you're asking a question, right? So you're asking from the database, for example, that I want to see all the students who are part of a class and also are born after a certain date, so to say. So if you would save that, let's say just in a file, let's say assume you just have a file with all the users, with all the students, you'd probably have to actually download all of it, go through each entry, and match which student has an ID of a specific class. And then after that, you would have to check for their birth dates and compare all of those. So of course it's possible, but if a program has to do that intensively a lot of times, it's a lot of wasted computed power, and eventually what also means it's a lot of latency. It takes a lot of time until your user is actually able to access some specific part of the data. So querying databases, it's something which you'll get a bit of basic today, but in general, there's people who, their whole job is to literally create queries for databases in such a way that the data coming out of the database is used in a specific, proper way, optimized way for an application. It'll be probably more clear once you get a bit of hands-on experience with this. So after you'll get all the knowledge on databases, you can say that you have learned the basics of the full stack. So what your hands-on thing that you'll do today will be that, you're making a small web server application, and you're connecting that to a database. So that's what we're going to do today. And in fact, that should be enough knowledge for you to make a full stack application, and later you're going to learn how to deploy it and actually make it available to people. Before I move on, any word here that doesn't make sense or anything that's not clear? Say it now while we have the slide on.
Could you elaborate on what you mean by fault tolerant?
Mm-hmm. Yeah, so fault tolerant, it means that it's hard to break. It's hard to do mistakes, if that makes sense. So if I mentioned, let's say you have all your data simply saved in a file. If a program opens a file while another program tries to open a file, and both programs are trying to write to that file, you might actually end up having a lot of garbage data in there, right? So, or also someone being able to accidentally delete a file is something usually not easily accessible in databases. So fault tolerant, it's more like it gives less chance of people or programs doing mistakes. Yeah. So that's kind of it. Anything else? Otherwise, I just move.
What about concurrency? Does each user get a copy on the fly, or do they get a view? How does it work?
Okay. Assuming that all your data is stored in one single computer, in one single instance of a database, the data is just there stored in one single place, right? But then a database also comes with a bit of logic. A database is not just just data stored on a computer, on a hard drive. It's also there's also an executable program that comes with it that makes sure that manages what comes in and what goes out. So that program will pretty much has some queuing mechanisms in such a way that if it got 3 requests from 3 users at the same time that I want to read this, I want to delete that, I want to read that, this program will make sure that it takes each query, each question, each command one by one and executes them. While just a file or just some data on a hard drive, it's dumb. It's just data. It's just some bytes. So if your program directly accesses some bytes, you might as well just break whatever the hell is there. But here you're actually interfacing with the database through different ways. For example, if you heard about SQL, you actually use a language for that. But there's always a small program that makes sure that it's fault tolerant and then you can have this concurrency. All right. With fault tolerant, do you mean that has ACID properties? That's also one of the things about databases. I forgot the whole meaning of ACID compliance, but I think guarantee. Yeah, exactly. So maybe you'll have that in an interview at some point in your life. So in computer science, ACID is a set of properties of a database transactions intended to guarantee data validity despite errors, power failures, and other mishaps. So that's the fault tolerant part. So maybe if you go for an interview as a data scientist or a database manager or whatever, maybe it's an important term to learn. Yep. So that's kind of the basic theory. So I see I'm already, some of the questions are going a bit more in depth. So, but before we go into that, it's very important to understand that there's very multiple types of databases. And what you see here, these are the 4, let's say, most used types nowadays. And the reason why there's multiple types of databases is because they're meant for different types of data, right? So optimized for different kind of applications. So the left one, the relational databases, this is the one that maybe most of you heard about. And maybe most of the people, when they think about databases, they think of a SQL database. So the whole idea of this databases is that you have multiple entries, multiple data types, and they're linked through some sort of an ID. And they're ideal for applications where, let's say, you want to make a system for a school, let's say, and you have students, classes, grades, I don't know, all sorts of information which is somehow linked to each other, which is very great when it's linked. However, not all the applications require this linkage of information. So the next one is, for example, the time series database. Let's say you want to, let's say you have 20 sensors in, I'll give you a real life example. Let's say you're a scientist and you want to predict the vibrations, or you want to predict a volcano erupting, and imagine you have 20 sensors around the volcano, vibration sensors, and you want to store the vibration amplitude, so to say, at every second throughout 5 years, right? So you can imagine that's millions of data entries. And if you try to fit that in an SQL database, I think in the first week you'll get to the point where your database can, like, every time you want to let's say check what was the average vibration in the last month, it'll probably take you, like, hours until you actually get an answer. And why? It's because these databases, the SQL ones, they're really meant for a quite big amount of data. However, it's not for enormous one, and it's really meant for entities which have some sort of connection. But if you're just looking at just a list of values over a long time, and also if it's a list of values which contains numbers specifically, time series databases are quite, that's what they come to save you with. Should all the tables in a relation database be connected with another table? So as a rule of thumb, usually yes, that's kind of the idea. It's not mandatory. But also another thing which is actually quite mandatory in an SQL database, and actually partially in time series databases, is that you have something called a schema. So what you see here on the left is not the actual data that goes in the database, it's a schema. And a schema, it's a description of the format of the data that goes in the database. And every time you want to add, for example, let's look at the example here on the left. Let's say you want to add a new customer. It's always expected that a customer comes in with a name, with an ID, and some other kind of information, right? So you're always it's enforced that you always, any entry that comes in with that data. And if you, let's say, don't provide one of these things, you will actually have you will still have that property, but with an empty name, something like that, if it makes sense. So coming back to this, time series databases, they're kind of optimized in such a way that if you're looking, if you want to see the average of a week, of a month or something, you would get that data really, really fast. So let's say if you would work in social media management as well, and you want to probably track activity on a web page, or you want to track likes of thousands of posts, and you want to have like a live plot of it, like in movies pretty much, or you would use time series databases. There are actually people working working in finance, right? In those who do online trading and this kind of stuff. All those plots that you see, if you'd save that data in an SQL database, you would have a really hard time. Like it would be basically impossible. The next type is graph databases. This is a pretty advanced one. I guess if you would start working in a company, most likely, graph database is not something you deal with right away. However, it really depends on what company you go. But graph databases are for data which is highly relational, in such a way that, in simple words, it's the kind of database you'd use for if you want to make a social media platform, if you want to see who is a friend of who, and also if you need if you're querying the data in such a way that relationships are crucial. right? So and you're always looking. So for example, SQL databases, you might send a query and you might ask, okay, as I mentioned, like I want to see the students who are part of this class born after this date, right? So this would be the number of relations you kind of expect. And sometimes you might add 2, 3, 4 more relations, but after that it kind of becomes not really optimal. But in graph databases, they're made in such a way that you might ask for 10 relations. Like I might ask, who are the friends of friends of friends of friends of someone? Or you're looking into, I want to see, I have 2 friends and I want to see how many groups do they have in common, right? So graph databases are really meant for that kind of stuff. And in general, the whole idea of graph theory. So in general, graphs, you might think that graphs means those graphs from math, the plots actually in English, though that's how you'd call them. But in general, a graph is, it's kind of like what you see here in this image. You have the nodes, you have the connections between them, the relations, and there's different types of relations. So those are graphs. And in general, if you want to, if you go to an interview at a large software company like Google, your interview will, honestly, I think like 100% have at least one question about graphs. So they're not only applied in databases, it's just they're applied in a lot of theory, in algorithms, and honestly, like a lot even outside the whole computational domain, I would say. Okay, and the last one, the ones that we're going to learn today, NoSQL databases, or and more specifically, document databases. So when you hear the word NoSQL, that's very generalized. But what NoSQL means, it's kind of like databases which are not like SQL ones. And the main characteristics are that you don't have an enforced schema. So it's not expected that every customer has exactly this parameters. Some customers might have, 2, 3 extra parameters that are not even part of any other customer. Some customers might have only 2 or 3 entries. So that's the first thing. And secondly is that relations between entities are optional. So you might have a lot of data, let's say in your website or in your application. There are some entries which simply they have no connections to anything else. There is just data that's there. So that's how a whole lot of NoSQL databases starting appearing all over the web. And I think the main reason why it's because web applications are a bit more they have more dynamic requirements than the typical usage of databases, right? So I think that's kind of the reason. You'll get a bit more when you'll work with it. You'll get a bit more idea of what's the point of the whole freedom that these databases give you. Another thing why they're great is because things are arranged in something called documents. But when the word document is not like an Excel document or a file, it's usually referred to like an object, which in most of the cases nowadays it's like a JSON object. And surprise, surprise, JSON comes from JavaScript, so that makes it a very great language for very great type of databases if you're working with JavaScript and you don't need to master SQL. Exactly. So that's another reason. In relational databases, getting certain relations right and writing the right query in SQL, because SQL is also a querying language, might become really difficult at some point. And people who dealt with SQL, they kind of know that, I guess. With NoSQL databases, you're much more free in your structure, and you really define the logic yourself. And again, what's also great is that the type of data that's stored in these documents can be whatever the hell you want it to be, because it's like a JSON, it's a JavaScript object. So it's also cool if, let's say, your application develops over time, which absolutely it will. Can I put audio in it? Yeah, about audio, I'm about to tell you how you'd store that. Also, if it might inspire you for your final project idea, because I know you wanted to do something with audio, but we'll get to that. So the idea is that, like, imagine your application, becomes better and better over time. And let's say, imagine you made a social media website. Let's say you made faces.md or something, right? And in the first version, you're only storing maybe, the age, the birth date, and 2-3 more things about the person. And now all of a sudden you add new properties. Let's say, oh, now I want to store a list of interests of that person, of like his favorite list of movie. So in the previous thing, you would actually have to redefine a whole schema for your database. Here, you just say that, okay, every time I add a new user, I also add it with an extra key called preferred movies. Is a standard store data to store data in JSON? Yes. So in most of the modern NoSQL databases, they really prefer JSON. In theory, I don't think that's like a required standard, but yeah, don't quote me on that. Pretty sure there's some database out there which uses XML instead of JSON or some other strange stuff. But JSON in general, it's a data format which is really preferred nowadays for this kind of stuff. So in no matter what language, so it's not necessarily JavaScript. So it's called like this because it came from JavaScript, but JSON, you would use it in honestly all the programming languages in the world. So C++, Python, whatever, like they all have a way to parse a JSON object and to stringify it. Okay, before I move on, any questions on the types of databases? No, cool. Yeah, so keep in mind, this is just the 4 most used types in, let's say, in web development, in application development, but there's a lot of other types of databases. There's actually, there's a very important type which I didn't mention. It's search engine databases. So for example, Elasticsearch was developed by one of the companies that I worked for some time ago. Those are kind of databases meant for search engines. So those databases, they work with just pure text, and the way it works is that you throw in a lot of web pages, a lot of text, a lot of information, and then those databases kind of look at what people are searching for every time, and they kind of become optimized. Like they would give scores to different kind of searches by the people. And yeah, I mean, I guess it's not a surprise that Google also has that kind of database behind it, but it's I don't think it's open source. It's not something you can just use yourself. But Elasticsearch, for example, it's used by Netflix and a lot of other services. The other also very typical type of databases, they're the ones optimized for geospatial data. So, for example, if you go around Google Maps, and every time you see, you move a bit to the left, to the right, and new stores pop up, new restaurants. If you'd store those in a SQL database or even in a NoSQL or whatever, if you'd store those there, it would take hours until a user moves to the left or right and new stuff appears. So, companies, like really high-end companies, will pretty much come up with their own systems if they're really. I guess that's kind of the idea, pretty much. Now, a bit on names of actual database providers. I don't remember really this link, but I think if you Google like database ranking, there's a lot of these pages. This is the one that I use myself. And here you can see the most, let's say, the most used database providers in the world. And you can also see how, like the trend, also something important. In the beginning, if you work as a developer, most of the times you'll definitely not be the person picking which database system you're going to work with. Most likely there's going to be some senior guy telling you that. However, once you actually want to work on your projects, and let's say you work on your own personal project, it's important for you to understand which one to use, right? So let's look a bit here in the top. So the first one is Oracle. So Oracle, it's used by really not a lot of companies, but by some companies. For example, I'll give a good example. So let's say Orange, right? You know the Orange phone provider in Romania, France, Moldova. They would actually use Oracle for all the information about phone calls, SMSs, and managing all that kind of stuff. Oracle databases are like very kind of corporate level databases. You usually need a lot of certifications until you're able to even touch one in real life. So yeah, some of them are like this, or like Microsoft SQL Server, or yeah, MySQL. So these are like the most used ones nowadays, but you can also see that the trend is also going down. And if you look at the most new projects, they would actually use more like document-based databases. We see search engine databases, so Elasticsearch, I mentioned about that. So the idea is like every time, RIP Fauna. Yeah, FaunaDB, that's a very interesting one. Do you see? It's not here. Yeah. So you see there's a lot of types, and you might think like, well, why didn't someone come up with one unique database which would work for any kind of type? And yeah, FaunaDB is one of those which I think it tried to connect to make it NoSQL, time series, and graph database. But honestly, it's a very expensive to use database in general, computational wise, and also if you actually want to use it in in production. So most of these databases, they are available to use kind of like semi-open source, or like you can pretty much just download it and install it on your PC and run it, most of them. But once you actually use it commercially, you have to start paying money. So it's the same about MongoDB. If you look at their stock price, they recently went public, and they are really making a lot of money. And why? It's because they give this free open source usage for developers. Use it for your own project until you hit a certain income, maybe let's say 100K per year or something like that. Until you hit a certain income, you are allowed to freely use it. But once you're a company making real money, then you also pay them real money. So that's kind of how you'd use them. So it's important to know that for every type of database, every project that you start, it's a very high chance that you're going to try a different provider. So yeah, that's what's the main takeaway. There are some of them which are like the leaders, but eventually these are just products, and we live in a capitalist market, and there will always be competition. Someone will come up with something better and so on. But what's important to know is that these providers will always try to keep the same kind of interfaces, the same kind of standards, in such a way that you as a developer, if you use MongoDB, you'll also be able to use Firestore from Google. And honestly, it will be nearly like the same kind of, like, you barely have to adapt your code for that. So that's about like the providers. Now, we had a question from Julian Yonel. So can I put audio in it? So probably what you've seen in all these databases, you don't see anything about images, video, audio, right? So let's say if you're thinking of where does YouTube store their videos, or where does SoundCloud or Spotify keep their audio? It's not in databases, all right? Because databases are not meant for huge bulk media files, right? So let's say you want to make let's say you want to make a meme web page, or you want to make a page like 9gag, so to say. What you'd have a database. Let's assume it's a NoSQL database, and for each post, let's say for each image, you'd have maybe a title. You would have maybe an ID of a person who posted that picture. You will have maybe, some comments or whatever kind of like information which can be, queryable, parsable, or understandable. And instead of actually having that whole image here in some sort of weird format, well, what you'll actually have, you'll have a link. You'll have a link to an actual storage. Right. So thinking of a good example. Okay. So for example, in Amazon Web Services, there's something called S3, which are like pretty much hosted folders where you just store files. Right. So Google also has something like that called just file storage or something like that. So basically, in your database, you'll only have a link to that image. Yeah, Firestore. Yeah. So Firestore is a database, and anyways, we'll get to that lesson. So that's the idea. If you want to store audio, video, images, you don't push them in a database. You host them in a file, and then you just have a reference to it, because otherwise your database will be hard to query. That's kind of it. And it's the same like the Facebook database. Let's say it's a graph kind of database, but all the images and all the stuff that you post is actually stored in something called like a CDN, a content delivery network. And a content delivery network, in very simplified words, is pretty much like a list of files or like a folder which is distributed along multiple servers around the world and are easily accessible by a lot of people. Right. So also that's why every time you open Facebook, it takes just some seconds if your internet is fine, because a lot of the data is already preloaded and it's ready for you. So yeah, I guess that's a long answer to your short question about can I store audio into it. Okay. So a bit more specifically on MongoDB. So what they officially call themselves, MongoDB is a source-available, cross-platform, document-oriented database program. So let's just go a bit through all these words. So source-available, I guess you heard the term open source. Open source, it means that there's this certain software project that people contribute to all over the world, and they do that just for the sake of making something nice for humanity, right? I mean, in very short words. But due to a recent scandal between MongoDB and Amazon Web Services, without going much into details, they said that we're just going to show the source, but we don't allow other people to kind of really reuse it in their own way. And so source available, it means that you as a developer are able to actually see the insides of that database system, of how it works and so on. So sometimes that's useful, sometimes not, I guess. Cross-platform means that it can run on any kind of operating system. Also something important, because back in the days, usually a database would run on a specific, let's say on Windows or only on Linux or Unix systems. So cross-platform means that if I run it now on my Ubuntu server, and let's say I want to now transfer it to some Windows server, it's just a matter of copy-pasting, kind of just running a command, and you don't expect surprises there. Document-oriented, so you've seen what documents are this like those big JSON files. And if we look here on the right, database, the MongoDB database has multiple collections. A collection is a series of data entries which are sort of from the same category, right? So you'd expect if you make a school system, you'd have a collection for teachers, you'd have a collection for classes, collection for each of types of entity, and inside it you'd have documents where a document is an entry of a student and so on, and inside that document you have all the parameters of the student. So classified as a NoSQL database program. So again, you already know that, and you can understand it from this thing. MongoDB uses JSON-like documents, yes. So I don't think it's an industry standard, but this is usually the case, that they use JSON-like documents with optional schemas. So in some places, you might want to make connections between different collections, right? So you'd say that every student has a list of class IDs that he is part of. So if you want to define that schema, that rule, then you can define it. And then if someone tries to, let's say, put in a new student in the database without defining a certain parameter, the database will give an error. But those are optional. So those are optional schemas. And and here on the right, so in case I didn't say what schema is a lot of times, it's a structure described in a formal language supported by the database management system. It refers to the organization of data as a blueprint of how the database is constructed. So pretty much you describe like what you expect your data to look like. And here on the left, this is how a document would look like every time it has an ID, so every document has a unique identifier, which is it's a very long string, and you're pretty much guaranteed that this is unique across any kind of document around there. And then the rest of the stuff, you just define it yourself. Now, a bit on, to get started with MongoDB. So in general, pretty recently, I would say, still most of the applications, like most of the applications that were developed, or like, let's say you as a developer, you were expected to install a database on a system, maintain it, and make sure it's always the latest version, and deal with all of that. However, nowadays, databases will almost every time be on a cloud, right? So it's very rarely that you have a database on a self-hosted system, like on your own computer. So you can actually just download MongoDB and install it locally in your computer. That's absolutely possible. But if you want to right away just get knowledge on how people really use those in real life, luckily, MongoDB allows you to create a fairly large database for free without asking any any card credentials or anything like that. You just you just go log in and create your database online. And actually, we're going to go with it right now. We're going to do it. In fact, that won't really be possible. So you'll have to really do these things yourself, because if I go on this page myself now, so mongodb.com, because I already registered and I went through the steps, I can't really go back. But the idea is that, you go on the mongodb.com, you sign in, or you click try free because you have to register. So here I'm going to log in with my, I guess, this account. So give it a second. You can open it and everything is new. Yeah, but then I still have to link it with a Google account or like an email. I should provide an email, which I'm really out of emails at this point because I've overused this a lot of times already. So my only account which do not have a database, it's Elitech. But don't worry, because it's really easy. It's like you just click next, next, next. The things which are important to take a look at. When you'll be asked which region you want to host it, you want to pick Frankfurt. First of all, because you're allowed to use it for free. And secondly, is because it's in Europe. So you don't want to wait for too much time every time you're reading or writing in or from your database. But after all of this, you'll get to such a page. Okay. So in this page, let me remember exactly where was I clicking stuff, because I rarely use this interface specifically. Oh, I think it's the wrong account again. Yeah, okay. I have to log in with a different account. Give me a second. This one was actually, it's actually running something in production. Should we go for it now or after the course? Honestly, like now, while I'm struggling to go on my new account, like feel free to just go on MongoDB. Just go on it and try to follow some of this stuff, and you're about to see where exactly you're going to get to. Because today in the lecture, we're actually going to make a Node.js application, and we're going to save a new database entry and delete one and list, so on. So we'll do some typical stuff. Just give me 1 second. Yeah, I should have prepared some of these things beforehand. I'm struggling here a bit. Okay, sign in. Log in with Google. Yeah, so you can, in the meanwhile, you can also go in there and try it out, because it's it's quite straightforward unless you have this kind of issues like me. I think it's because I tried to log in with a different account. Okay, cool. So if you follow this instruction, you'll get to pretty much this page. You'll see it here in the bottom right. You see the same interface, and we see that we have something called cluster 0, without going much into the theory, a cluster is just like say a physical place where you store information, and it's like I guess it makes more sense if you speak about distributed databases. Here it's like really straightforward. It's like you create a new database, it should be part of a cluster. So inside this cluster, we click on collections. Collections, please. Yep. So by the way, is my internet fine? Like, do you see me clearly and so on? Or is it just this page being bad? Anyone?
It's okay for me.
Okay, so I guess the MongoDB web page is a bit slow sometimes. So what we inside this cluster, normally you wouldn't have anything here, but what you're able to do, let me zoom in a little bit. There's a button called Create Database. So once you click on it, it's very simple. You describe a name of it. So I called it school, for example. And then a collection name. So the idea is that a database has multiple collections. So coming back to this slide, a database is meant to have at least one collection, right? There's some lag between the video and audio. Huh, okay. All right, good to know. Yes, so you're asked to provide the first name of your first collection, so maybe students or something like that. Yeah, so after you created it, this one I called it my first database, and this database has one collection called students, pretty much. And I think I already had some documents in it. And this interface, there's also another interface that you can download on your PC. It's called MongoDB Atlas. If you want this in a nicer way, and if you don't want to deal with all this lags that I have here, you know, like yeah, it's quite slow. You can actually download an application which looks pretty much similar like this, but it just runs in your Windows PC. So here you're actually able to do things manually yourself. So you can insert a new document, and here you're able to create, define a new key. So let's say name. You can give it a name. You can define which type it is. So each each key has a value, and you can define which type is that value. But sometimes some of them might be they can also be not undefined. Was it any? Some of them strange. Cannot really find it, but anyways, what you want most of the times, like I would say 99% of the times, you want to define which type your values are, right? So you can create a name, then you create a new field, any key, any value. You do inserting document. So what I see here, so you'll see how I created this tree, but what you see here is that here I have 3 objects, and all of them have a name, an age, and a gender. They all have an ID, so that's by default. This is not something you can really not have. I saw null. Yeah, I think null is more of a type, but really, like, try to limit yourself now to strings, numbers, and arrays, or objects as well. That's also possible. But because this is a NoSQL database, you see that I'm able to have 3 entries which all have the same kind of structure, and I have this one which is a bit like completely different. So in a SQL database, the system would give an error because everything in the same collection is meant to have the same structure and the same type of values and so on. So here you're able to freely define things as you want them. So I'm going to delete this for now. I'm actually going to delete all of them. And before that, like, on how to use this interface, I'm not going to go much into details because there's a lot of stuff you can do here and a lot of stuff you can learn. But one of the things here that you can do is that the query language, so like the way you can sort things in database, they also use a JSON kind of structure. and I will give you the link to official documentation, or I mean, you can really just find MongoDB official documentation in which they explain you how to form a query. I can definitely tell you it's much easier than SQL, and I'll give an example. Let's say I have these 2 database entries, and I want to see students which have the name Valera. Let's say I'm just going to copy this one. Did you copy? Copied. Clone. Yeah, there we go. So I'm going to clone this one. Yeah, so as you can see, I have 2 entries which look very similar, but obviously they have different IDs, so you're not allowed to have the same ID. And the system will always make sure that's not possible. But let's say I want to see the entries of people who have a specific name. So I can pretty much say name Valera. Find. Yeah, so we got those 2 entries. If I want to say, I want to see people who have over a specific age, then I have to use something like, actually, it comes in the next slide. 1 second. Just give it 1 second. Yeah, a bit of spoilers around here. Right here. GTE, yes. So, for example, just another one. You'll learn those things yourself, but just one typical thing that you can do with this querying language. Let's say I'm looking at age, and I want the age to be bigger than 20, I guess. And I do find. And actually, I will get the same to, actually 3 of them. So this specific instruction here is something that you just learn. You get it from the documentation, nothing really special. So, so the way it works is that you define a key and then you give it a specific instruction. If you do this in SQL, you would have something like, select students from somewhere, and like you say, where age bigger than, so you would actually write something like this with big letters, so people know that, for some reason SQL comes with it's always expected that you'd write big letters. Honestly, I have no idea why. So anyways, this is some very basics on a NoSQL database and how you query data from it. However, you rarely, in a NoSQL database specifically also, you rarely need to kind of edit entries yourself and add them. So what I'm going to do now, I'm going to clean this up. And we're going to go to the part where we are making where we'll make a program that adds entries programmatically. Yeah. So let's delete one by one. Yeah. So clear everything, reset. So, okay, so now our collection in this database is empty. So what we want to do now is actually to connect to it. So coming back to the presentation. Yep. Right here. So I very vaguely, I guess, described how to kind of get to this part, right? Like how to actually have a database on your own. So this is completely free if you hosted it on the Frankfurt server. And this is pretty much it. You can get familiar with it, and like actually, if you want to really get good at it, you'll have to kind of try some of this features yourself. There's different ways like to visualize your data, to group it, and there's even like, performance advisor. Like if you have a large data set, it might tell you like, oh, maybe you want to get rid of certain keys because they're not used that much and so on. So it's quite a really powerful tool, but for now we're just looking at the basics. The next part is to, actually to connect to it, let's say through a Node.js application. So in Node.js, there is a library called Mongoose. So if you go on npm, here. So this is the library. You can see 1 million weekly downloads. So definitely a very used library, probably one of the top used JavaScript libraries. And here you'll have all the documentation on how to connect to a MongoDB database, how to define a schema, how to do pretty much all the basic stuff that you need. You have all the examples here, and we're going to go through some of them. And then you actually have the documents, like the official documents on where you have information about every small thing that you can probably do with a MongoDB database. So yeah, installing it in a npm, in a Node program, you do it like you did with Express.js or any other package that you tried or didn't try yourself. So npm is I or npm install Mongoose. That's it. So that's the first part. And since we're at it, let me actually make a new project. I'm just going to open a random folder here. Example, I'm going to select this folder. New file. And we're going to start a new Node application. So Ctrl+. So that's something I learned in these lectures. So is the text readable here, pretty much? Anyone? Like, can you read? Can you turn off and on the sharing, please? Maybe the streams will synchronize. Yes. Okay. Yeah, let's try that again. I'm really sorry. Oh, I see I'm in quite a poor quality. I think I'm going to connect to my data. Yeah, just give me a second. Yep. See you in some seconds. Am I online?
Yep.
Better.
Yes.
Cool. Now let's see how the sharing works. All right. Okay. Because I also have another PC here which logs the stream and doesn't seem really terrible, but yeah. Anyways, let me clean this up. Okay, so can you read text here? Like, is it more or less readable?
Yeah, it's very good.
Okay, cool. So stuff that we learned last time, npm init, we're going to start a new project. We're going to call it database, whatever. Enter everywhere. Everything is okay. Yes, we have the package.json, and now we're going to do npm install Mongoose, right? You can click this here as well and just pretty much paste it. Oh, no, not all of this. Sorry. I should have just npm install Mongoose. So we install it, yeah, a long process, downloads everything, sets everything up. It's going to create your Node.js folder. So I guess for those who worked on the assignment, not really a surprise, but okay. Yeah, meanwhile, while this, okay, so this already installed. So I see that Mongoose came with a lot of other libraries, which are dependencies. So we see, yeah, all these libraries right here, but you should not really care about it because you're only interfacing with it. So you're not developing the library yourself. So that was the first part. You install Mongoose. The second part is to, get some sort of credentials, some sort of, basically your application should know where is your database, where it should look for. And of course, you most likely have some authorization. You don't want the database to just be available out there in the world, right? You don't want anyone with the internet connection to be able to just add and delete entries out of it. So we're going to use some very basic authentication with passwords. So to actually get that password, the way it works is that you have to go to network access. Database access. You want to add a new database user. So here you're given this page. You have it in the link here as well. And I chose password, a very simple one, but for professional use, normally what you do, you use like a certificate, which in very simple words is like very huge piece of text in a file, which identifies you. It's quite simplified. But yeah, to make things a bit simple, we just are going to use a password authentication. So yeah, just pick password, create your new password. You want to create it, don't show it to anyone. You can also auto-generate one apparently. And then you want to say which kind of access do you want it to have. So read and write to any database, that's good enough for a web server application for now. And then you click on add user. I'm not going to do it because I already have a user, right? I can edit him and I'm not gonna edit the password. So now you have that user, okay? So you click on create, and then the third part, there is another menu here, which is connect your application, and that you find it here in clusters connect, right? So back to this main page, you see here connect, you click on it, and what you want to connect with, you want to connect with your application, right? You click on that, and what we see here, so what we see here, we see this very interesting link, but we see password here, it's not really shown, right? Because you'll have to include that yourself. And also, very important to tell you now, when you post your project on GitHub, on a public repository, actually any repository, even if it's like semi-private, you don't want to store passwords, API keys, or anything identifiable. You want to store those only on your computer, and your program should find those. Usually you store them in a separate file or in whatever, but you don't want to commit and push those online. So that's a very important piece of information, and keep it in mind because I think only in the last year there's been like thousands of hacks because people would put a password or an API key on a public repository, and in fact anyone browsing on GitHub can find that password of yours or like this whole link, and then if they have it, they can actually access your online database, play around with it, and imagine you actually have serious data there, like transactions or personal data. You know what can happen, of course. So they even give you a include full driver code example, but we're not gonna look into that. So this, you want to copy this, and now we're going to paste it. So this is step 4. And now the next step is to go to the code to actually paste that URL. So this code, you'll get it on GitHub as usual, without my credentials. So you'll just copy paste this code, put this credential, your credential, so the one that you got right here, you'll copy it here. And now let's analyze a bit of what's really happening here. You import a library called Mongoose. You do it in this specific way. And then you do mongoose.connect. And as a first parameter, you give it this URL with your password. And the second parameter, it comes in as an object with a lot of optional parameters and settings and configurations. It's not really important to understand all of them now, but just pretty much copy paste this object as it is. And then you want to, you create an object called DB. you can call it whatever the hell you want, but it has to, it's you create it from the object called mongoose.connection, and this is the object. This is a variable that you're going to use throughout your program to interact with your database. Also very important, you already learned a bit about asynchronous. So as when you're defining APIs and working with real life applications, you've seen that not everything is synchronous in this world. And a connection to a database, it's a connection somewhere online. It's also not something that happens instantaneously. So you don't want your whole program to be stopped, when while waiting for a connection. So you have to use event listeners. That makes sense. So you want to pretty much say start connecting now, and then you want to say what do you want to happen once you're connected to the database. So here, DB once open. So this construction, just as it is here, takes in as an argument a function, and this function will run if you had a successful connection to the database. So here we're just going to print something, and if it was not successful, we want this to run. So you can find this in the official documentation of Mongoose. I think there's like 2-3 other ways to do it, but again, this is JavaScript, so this is one of the ways to do it. I do it this way. So so if you will run this code, you'll get it on GitHub. This is the first step to do, to check if you have a connection to the database and if you followed all the steps correctly. What I'm going to do, because I already have this code, I'm going to copy paste it from somewhere. From here, yes. So I'm going to copy paste it. Yes. So as you can see here, instead of writing the URL as it is, I created a variable, and inside this variable, again, do not push this to GitHub. Inside this variable, I am going to copy paste my ID, if that makes sense. And give me a second. Copy. And I'm just going to go right here so you don't see the password that I put in there. But in fact, it shouldn't really matter. It's just I'm worried that this video goes on YouTube after that. Give me a second. Let me think, how can I do this? I'm looking for the password. I just forgot it, so I haven't used this in a while. Database, access, edit. 1 second. I'm going to change it right now just because I don't really remember it. Yeah, so I'm going to change this password right after the lesson. So for now, I'm going to use just a 1, 2, 3, 4, 5, 6, 3, 4, 5, 6. So that's the URL. I want to do a connection. This is exactly like in the slide, so nothing. You can change it after. Yeah, exactly. I can change it after, right? So on error, I want to say that I was not able to connect, and then once I'm connected, DB on open. For now, asynchronous is not necessary, but you'll figure out later that you'll want to make it an asynchronous function. I want to say connected. So we're going to run that now. So node index.js, we want to run it, and it should tell me something at some point. Yeah, I did get an error, and I think authentication failed. I think I forgot to, something with the password, I guess. Let's see, edit password again. 6, 1, 2, 3, 4, 5, 6, update user, cancel. Yeah, maybe that link has changed or something. Just give me 1 second. So I'm gonna copy this again. And this will be 1, 2, 3, 4, 5, 6. What the hell? Authentication failed. Is the name of the DB correct in the link? Good question. My first database, yes, that is correct, but it still tells me, I think it has a problem with the password. So very strange. I think users don't update that easily. So let me try the old password just on this other screen. One second. Okay, that is really strange. Yeah, quite unfortunate, to be honest. Let me think what would be the best thing to do here. Yeah, so yeah, debugging, it's part of the part of the job, right? Yeah, I honestly have no idea what's happening here. Let's see. I think you're confused with the MongoDB account password and user password. You should use the user password, not account password. That was the reason of my case, Stack Overflow. Thanks. Whitelist the IP. That's also not a problem. Also, something in case you have the problem with so that's a bit about the other issue. So if you don't have access to, you might also, what you can do, you also go here to network access, you go to add IP address, and then what you want to do here, you would write just 0000 slash 0. That's pretty much it. And then that means that you're allowing any IP address to connect with. It's usually not very secure, but it's not a problem because you still are authenticating with a password. So that's not a problem. Actually, I think what I'm going to do now, I'm just simply going to create a new user. That's kind of it. So database access. So we're going to the user. This is the password. Add user. And yeah. Choose a connection method. Yeah, application. And yep, we're going to copy this. Come back here. And right here, we're going to say the user. And this is going to be the password. That, yeah, with a small u. Did it work? Yes, great. Okay, so making a new user solved the issue. Honestly, I have no idea what was the issue, but yeah, maybe you'll figure it out. So at this point, we haven't really done much. We just connected to the database and we just proven that we connected to it, but we haven't done anything. So also what's important to note is that any database operation that you want to do it after you ensure that you're connected to it, right? So I'm about to show you how to add and delete new entries. So that code, you don't want to add it here after that. You want to add it in this small callback function right here, right? So that's an important thing. Because if you write it outside, then it's going to tell you that you're attempting to create a new entry before you were connected. So yeah. Now, back to the presentation. So this is what we did so far. Now the next part is to defining schemas and adding new data. So again, schemas are optional but sort of advisable. Here we're going to define a very simple schema with some of the parameters. I think they're not necessarily mandatory parameters, but in Mongoose you kind of have to sort of define a schema or something called a model, and a model is also a connection to one of your collections, right? So now we're looking at the collection called students. So we want to first define how does a student document look like. So this is how you define it. You create a new variable, a constant, should be a constant, and you want this is how you write it, new mongoose.model, and then you put the name of your collection, that in which collection you want those kind of documents to go to, and then you create a schema. And to create a schema, you do new mongoose.schema, and inside it you put an object. And this object, I think it's quite self-explanatory. It's like a key and the type, key type. So here we're looking at very simple types: strings, numbers, booleans, and then arrays a bit later. So for every collection that you have, you will create a new model with its schema. So that's important to note. So this object, you have to have it has to be accessible then, because normally you would put this in a different file. Like when you work on larger scale projects, you kind of organize your documents like in a much nicer way. And this is probably in a separate JavaScript file, and then you import it. But the idea is that this object has to be accessible wherever you want to deal with a student collection, right? So now we're going to make a function called createStudent. It's an asynchronous function because a writing, a reading operation, just like in the case of APIs, it takes time, and you don't want your whole program to be frozen while that happens. So I made this function, and I say that this function takes 3 arguments. So this is just something out of my mind. And what you do there, you create a variable, and you say that this variable is of type student model. I don't know how you would really say that, but you kind of use this variable student model, and you use the word new, meaning that you're creating a new entry of that type, and inside it you put an object. And in this case, I'm pretty much just copy pasting the arguments of the function and putting them there. I can also write that, like I can actually hard type things like actually writing a name here, an age, and a gender. And I made the gender Boolean, so I'm sorry if that makes anyone angry in 2021. Shouldn't the callback function also be async in this case? Let's see. Yes and no. I mean, it's not mandatory. It's simply that we're not really waiting for anything there. So ideally, yes, but it's okay. It's okay like that as well. So after you created this, this information only exists in your Node.js application at this point. To actually send it, you use the newly created object and you do .save. And you do it with an await because this takes time, right? And it's an asynchronous function. You can also, I think optionally, if you don't like async await, inside the save, you can put a callback function explaining what should happen after you saved your object. But that's kind of it. But this is like much cleaner. And then here, just to make sure, to see when that happens, I print out the new student has been saved in the database. And what I do in this code, once I open, so we've seen this already, I have a callback function which runs when the connection to the database was initiated. And I say I want to run this function 3 times with 3 different arguments, okay? And what will be the result of it? Unfortunately, I cannot go hands-on now because, you'll have to try this yourself because this will take too much time. But I guarantee you that if you do not get to the bug that I had before, this should work right away, as it is. So this is, in a very simple way, how you save new data in a collection in MongoDB. And the result of it will be that once I go into that interface, I'll see those 3 objects. And actually, you've seen them at the beginning of this lesson. You see that all of them were created. An ID was created right away. And we see that Mongoose also creates something called V, like a version. It's something that it's optional, but it's actually nice because every time you would update a certain document, this V will increment. So it's actually very important in some applications to know if some data was changed, but that's kind of it. So it's quite straightforward. You make a JavaScript object and you kind of push it in this database, and they are called documents all of a sudden, but you see the same key values. They have this unique IDs. So definitely try this on your own. The next part is to actually, reading some data from the database. Because that's quite important, right? And we are going to read specifically. So when you read, you'd never want to just simply read all the data in your database. That doesn't really make sense. So here, let's start with the first function called getStudentsWithName. So you've already seen me doing this at the beginning of the lesson. You've seen me doing this with the interface, right? When I was writing that stuff in that interface, I guess, in case anyone forgot. So you've seen how I did that right here in the filter, where I was saying that I want students of a specific age or with a specific name. So it's very, like, you pretty much use the same code, the same query. But now coming back to how do you actually write that. So here I made a function called getStudentsWithName, a synchronous function again, takes as an argument a name, I guess, obviously. And so to query, you use the next construction. You write, you create a new variable. You expect it to be an array because every query will return you 0, 1, or multiple elements. So they come in the shape of an array. And you do, again, await because, again, this is something that takes time and so on. It's an asynchronous function. And you use that same variable, student model, the one that we defined right here. So this student model, but instead of doing .save as we did, creating a new one and .save, the way we find a new one, we query, we use that model dot find. And the argument of this find is that query object that you've seen as well, me using in the interface. And if you want to get more specific ones, to learn more like advanced queries, you'll get them in the official documentation of MongoDB or Mongoose as well. So I think you'll find them in both places. If I want multiple conditions, if I want them to have a certain name and a certain gender, I can just simply add a new key called gender, and I can say, do I want it true or false? And then with numbers, there's some operations, there's some Boolean operations, there's a slide about it. And then what you do, you want to return that data and you want to print it. So what we do here, again, once the connection to the database is established on open, here I'm just printing some text so it's clear what's happening, students with the name you on, and then I await, it's an asynchronous function. I want to say get students with name you on. So this happens, it returns to me, and now this is what I had in the database at that very moment. So I had the list of 4 users. 2 of them were called you on with 2 different ages. And what is being returned, it's returned a JavaScript object. I don't even have to like parse or play around with stuff. This is an array with those 2 objects, and I can do stuff with them right away. No need of, parsing or doing any extra stuff. So so this is what the response of this function. And then it's an array of the 2 objects that I don't think there's anything else to say here. And then the other function is, unfortunately I put an image here, but just in case, so you know which code is that. Similarly, I made a function for you to get, for example, students with an age greater than. So you've already seen this object that I was using at the start of the lecture directly in the MongoDB interface. So exactly this now goes here in the .find of the student model. So you'll get this an example, you'll try it yourself. So again, this is something you get from the official documentation of MongoDB. There's also something like equal, I think that would be EQ. So that means that I want students with that exact age. So there's multiple of them. I think I have a slide on those. So here, this is what I have in the database. This is another function, about like to get students with that bigger age, with an age bigger than a certain number. And this is answer. So this is pretty much it, listing and getting information from a database. The next one, so the operators that I just mentioned. So you've seen me using GTE, so matches values that are greater or equal than a specific value. If you go in the official MongoDB documentation, you have here all these operators. So here, this is like number operators, or was it like not logical comparison query operators? So here we're like looking at bigger, smaller, and so on. So for each of those things, they have a different like function name. So every time you'll need something, you'll Google it, go through the documentation. You definitely don't need to learn all this by heart. But something important, really, really important about databases, one way, technically possible, if I want to get students with a specific age bigger than something, what I can probably do, I can pretty much ask for, give me all the students, load them in my Node.js application, and then writing myself a for function that goes through each of them, and it checks if they're higher than a specific age. Technically, yes, possible. But the moment you start having 1,000 students, and every time you need to search for a list of students, it will take a long time, right? And you don't need that. And this will be a lot of traffic there and back. And that traffic costs money and time. So every time you're able to do some sorting in this query thing, in the .find, try to do most of the sorting there and not on the output, like not so basically you want the database to do that sorting job for you and not your program to do it, because databases are optimized for those kind of operations. So now we learned how to add and to read data. And the next logical thing is how to delete data. So for that, so deleting data can be done in a lot of ways. You can delete a specific object by ID. That's the most simple way. But you can also delete a whole group based on a condition. Here, you'll learn multiple ways to delete objects if you look in the Mongoose library. But here's a more simple one. It's called find one and delete. And find one and delete, it means that, again, I put here that query object. I say that I want an object with an ID, so this key that it was created automatically, and I want that ID to be something that I pass to this function. Okay. And find one and delete, it means that even if, let's say, I put the name Ion here, and I have these two objects, if I put name and then Ion in this query object, then only the first one will be deleted. There's other function, I don't know its name by heart, but there's like find multiple and delete, I guess, or something like that, where it will delete all of them which meet a certain condition. So depending on the requirements of your applications, you'll find different ways to delete. So here what I did, I looked in the database myself. I saw, okay, this object has this ID. I copy-pasted it, and I ran this function with that parameter. And and that object was deleted eventually. So try this yourself, and and you'll see how it works. So any general questions on the stuff that I've shown here in the hands-on part? because after that we're going into something completely unrelated. I'm surprised that you don't really have any kind of questions. Maybe something that you want. What would be the output? Yeah. What would be the output of this console log?
How do we connect?
Yes.
How do we connect it with the REST API part?
Okay. I'm getting to that. First, the question of Nikita Burlaka. What would be the output of this console log you show right now? Yes. So all these operations that you do with Mongoose, they return something or nothing. So what in this response, also you can check the documentation, you will have the object that was deleted. So let's say, after you do this, that object is deleted from the database, but here you have one last chance to do something with that last information, right? Maybe you want to print that this object with .name was deleted, or maybe you want to send a notification to somewhere. So before it dies, it's the one last thing you can do with that data. But what you would normally do, you want to at least check if this response is not null or undefined, because then you're sure that the object was actually deleted and it was found, if that makes sense. So in the saving part as well, it works the same way. So yeah, so I think that's kind of the answer. And you asked like how to connect this to the REST API. So let's say now you define one of those Express.js APIs. That will kind of be partially the thing to explore on your own. But the idea is that, let's see, what do I have here that I can show easily? So yeah, I'm going to open this whole lectures thing. So my first API. So now, coming back to this basic example, we want to get the list of fruits, right? And what we do here, we had an empty list, very simple. We saved that in an object inside Node.js. So that's, that object disappears after you leave. But now, instead of just sending this, what you would do, coming back to what we're currently working on, lecture 7 in Exo.js. Let's say we have this student model, so that obviously has to be there. Of course, you have to have the whole Mongoose Connect and so on. But what you would actually have, get students, something like this. Oh, sorry. So you would have that function there. Here, this would be synchronous sync. You would wait for get this, let's say. Something like this, I guess. And then you want to, and normally you don't want to just directly return those students with all the IDs, and maybe you just want to say like for like students for each, and then you maybe want to take only certain keys out. But this is very, very simplified how you do it. So every time someone sends a request, like an API request to your application, then you go to, okay, now I'm going to ask the database to give me something, and then I send that information back to the client. Normally, this is done a bit more complex. So first of all, you want to check if the request of the user makes sense. You want to validate that. You want to then read the information from the database, and then you want to only maybe get certain keys or parameters. Is that kind of clear, or do you? Or
Thank you. It's cool. Thank you.
Yeah. So that's the whole concept, and I mean, like 99% of the web applications out there, web server applications have pretty much this role of just, getting a request from the client, asking something from the database, and then sending that information back to the client. And then the front end, your web front end application, that one then is meant to show that display in a nice way. Can we do stuff like getting some keys on the MongoDB side? You mean not getting all the keys, but only specific ones?
Yeah.
Yeah. Okay. Cool. So that is possible. I don't have that really exactly by hand, but let me Google that for you. But that's definitely possible, and that's very advisable.
I
Yeah.
can Google it. I
Oh, yeah.
just ask if it's possible.
Yeah. Actually, it's also advisable because imagine your your document model is huge. Like, let's say you have like 20, 30 keys, 50 keys, where I'm not sure the physical limit, maybe it's like 1,000 something. So you don't, if you are only looking for student names, right? Because you want to print those in a nice list in your web page, you don't want to download all the information. So then you can actually specify inside here. I think you add it as another argument. Yeah, inside here, you add another argument. I don't know it exactly now, but you can actually say that I want only this key. You give it an array or something like that. And not to use extra traffic. So yeah. Okay. Any other questions around the code? I mean, now's the chance. I mean, of course, you're able to also give me questions next time, but before you get hands-on, yeah?
Is there a better way to work with the objects except the ID, because it's a very long string? Like, how do we keep track of?
Yeah, so realistically, you'll never explicitly type IDs in your code. Pretty much never. You'll always use some referrals. So here I'm only showing very in a simplified way how to delete something by ID. Honestly, I don't think you'll really need that ever in an actual application. Let's say your front-end application gives you an option to delete users with a specific name. So what you actually do, you find those, you get all those IDs, and maybe then one by one you delete them, or you never really work with those IDs. That's the idea. Like,
okay,
yeah,
cool.
Yeah, and then later, okay. Question from Nico Gajduk. For example, we have students DB and each student have 2+ projects. How can we store this in MongoDB? MySQL, we have to create another table where we can link projects ID with student D. Have you understand the question? I completely understood the question. So that's something which we will not have much time to go into now. But the way I will send you a very nice YouTube tutorial that explains that. But in very simplified ways, you would create another collection, right? So here, and you would create it here in the interface. So inside here, my first database, you create a new one, you say collection name, and you'll call it teachers or whatever you want. And once you have it, you'll just have another list of elements, or a list of documents. Once you have that, you'll need to define another, where was it? Another model. So you'll have a student model, and then you'll also have you'll have a student model, and you also have a teacher model, or whatever you want, project model. I'm sorry, yeah, based on your example, and you have multiple projects. And now you want to say that the student has those 2 projects. So to do that, there's a type in the schema, and actually, without writing code, that's possible to do just in the interface. I think I might just be able to do that. So let's say project. You'll then learn how to do that programmatically. So I have students, I have projects, and here what I want to do, I will insert a document, and let's say name of the student is, Yuan, whatever, and then I'm gonna add a new key, and here I'm going to say projects. And here, the projects, I want them to be of object ID, right? But this means that only one person can be connected to one project. So that's not really great. What I want to do an array, yes? And I want the array to have multiple elements of object IDs. And then I can add multiple of them. Another object ID. So let's say I want to insert that. Those object IDs are currently, Zoom, sorry. Yes. So we see that he has a list of projects. These projects do not exist yet. But now if I go here and I actually create a project, I'm going to say cool project, insert. then what I can do, I can pretty much, I can pretty much copy this ID. I copy this ID. I go to students. I go to this entry. And one of these IDs, I want them to be a valid ID of a project. There you go. So now, in the way I will deal with it in, let's say I want to get all the names of the projects of a person called Yuon. Then what I would do, I would first do that student.find, and I say that name is Yuon, right? So that's something that you already seen. And then what I do, I want to also get that students, the students' projects. But what you get, I just get a list of IDs. And then for each of those IDs, then I do project model.find, and I find projects with that ID. And then once I find them, I want to get their name. So that's the steps that you would take. And the only link in this database between them two is an object ID. So object ID, it's of a type. So what you'll Google for, you'll look into how to add an object ID type in a schema in Mongoose. So here you have name, age, gender. There'll be another way to add array of object IDs or just an object ID. Yeah, all right. So, okay, time for one last question about MongoDB and Mongoose. Nothing? Okay, all right. So just the first question. Do you think the amount of information today was, let's say, more graspable, more easy to understand than the last time we spoke about Node.js and Express? Yes, cool. Sure. Yeah, all right, cool. Good to know. Now, some very practical matters, a bit about our lectures and about the rest of this course. So, in total, the plan is to have 12 lectures, right? And so far, we have done 6, and today is the 7th lecture. So we're left with 5 lectures, and there's a lot of things that we kind of thought we are able to do, but we're not. Give me a second. So we kind of have to choose a bit on some priorities here. So we kind of thought like, okay, what's really crucial? What's really possible to learn in 2-3 days? I've also looked at some of your questions about where we're going to learn this or that. So kind of like, this is the list of things which are still left to be done, more or less, at least based to original plan. So realistically, we have 5 lectures left, and we want to do the following. So we want to learn React. And for the basic level, we really need 2 to 3 lectures. It's not something you learn in one lecture, unfortunately. In one, you might get a bit of basics. You might start on your project by working with React, but we need 2 to 3 lectures to really learn React. The group assignment is also something that ideally you would work on for at least over 2 or 3 weeks, right? So you kind of, I guess you'll have busy schedules as well, so you don't want to make something nice and cool in just 1 week. And so 2 to 3 lectures for that. Firebase and Google Cloud, just the theory and the demo by being shown from my account, that would be 1 lecture. And that's some nice information because, I mean, honestly, knowledge on any kind of cloud platform, either Google or AWS or Azure, makes you a very employable person in the field. So I imagine this is something really, let's say, attractive to you. However, actual practice with Firebase and Google Cloud, again, you need maybe 2 to 3 lectures. So you already see how things are not really fitting now. We want at least 1 final lecture to be about your projects. So you can present them. We can, take some snapshots, some videos, put them on the social media. Make yourself proud, make your family proud. So we want that for the last lecture. And also project proposals is something that also has to be done for at least half of the lecture, because you first have to explain to people why you want to build something, and then you build it. So this is the situation that we are in. And now the proposed solution, this will be a bit more complicated than information about databases, but let me try to explain you this. You see my mouse, right? Yeah, okay. So I propose that in the next 3 lectures, we are going to learn React. So starting from the next time, we're going to start again with the first part of building websites, but now you're going to build them in a much modern, advanced way. Some people might say it's actually in an easier way once you actually understand how to use React. So next lecture would be about the very basic theory about React, a bit of hands-on, pretty much making the same easy websites that you did so far, but with React. And then we'll go through the more advanced stuff. So then you really can put that React in your CV and be confident that when you go to an interview, people can see that you know it. The next thing is, next lecture, you would show your project proposal, which means that until next time, you should already find out who you are in a group with. I made a very simple Excel sheet. I'm going to put it in Slack. It's an open Excel sheet. Everyone can edit it the way you want. So I'm going to assume you're all decent people, so you're not going to start breaking it and typing things all over. So in there, you're just going to, I made a list of groups, and you just kind of put your name wherever you want. You can speak with people in the chat. That's a very bold assumption. I don't know, like we kind of did a filtering of CVs, right? So I know I kind of expect some decency from you people. Yeah, so you'll type in your name there. If you're clueless of who you want to work with, just put your name and your favorite number, and then maybe someone appears there. I would suggest groups of 3. Groups of 2 is also fine. 4 is fine if you really know what you're building and you have a very clear understanding what each person would contribute with. So keep that in mind. So after 3 lectures of, so we'll get back some questions. We'll get back to the project, but now again to the last 2 lectures. The pre-last lecture will be a bit of theory on Firebase and Google Cloud. So I'll show you just on my computer how it runs, how how you pretty much host your web page, host your project. Yeah. In the meanwhile, in this 2 to 3 weeks is when you actually work on that group project. And then in the last lecture, we do project presentations and then send some the PDFs around with like the certificates with your names, and then you can post that on social media and show that to everyone. So good PR for you, good PR for ourselves. So that's kind of the plan. And now I'm expecting your feedback. What do you think? Or questions about the project proposals and so on? Good plan. Looks good. Okay. Cool. So the project proposals, I highly suggest that you do it in one single slide. And that's also very important because it also teaches you a bit of I don't know how to say, like we now live in a world where the attention span of people is really short, right? So people just want to see something like a poster or like a very short piece of information, and they want to understand everything out of it. So I think I had it right here. Never mind. I'll get to the next slide. But the point is that, till next time, make sure you pick a group. Otherwise, I'm just going to randomly put people in groups. And then the next time you come up with a proposal. what do you have to do, pretty much. Until next time, fill in your name in that Excel sheet that you're going to get. Brainstorm about project ideas, and contact me in case you need guidance about like complexity or technology choice. Like, for example, Julian, like I know you wanted to do something with audio, so maybe ask me a bit about some libraries that you might use or so. Or like if you want to make some image analysis thing, or I don't know, something quite advanced, then ask me. Maybe there's an easy library that you can use. Otherwise, I'm going to guide you maybe in a different direction or so. Also, till next time, explore MongoDB. Try all the stuff that I showed in the video. In the future video. And ideally, if you have time, you can the list assignment, the one that you've been working so far, adapt it in such a way that you're using a database instead of that object variable, right? So the idea is that the certificates, like I think most of the people who are here are highly active and they're doing whatever like they have to do in the course. Like they've proven that most of you have proven really that you kind of learn new stuff and you know the stuff that we taught you. However, like in the end, when we give away those certificates, we'll go again through the list. And if, let's say, you did not manage to work on the personal project, or you simply we haven't really seen you around, you haven't seen your name around or so, like you can use this project finalized with a MongoDB connection to kind of say like, look, I made this and I've proven that I know stuff, and then we can confidently give you that certificate. I mean, honestly, that certificate is just a PDF with your name and a stamp. In reality, what it is that every time you're going to tell someone that you know JavaScript and you're going to show them this certificate, there's a high chance people are going to call me or call any person from our company. And we don't want to get in a situation where there's someone who, goes out there in the world, tells everyone that I know basics JavaScript, and then, that person doesn't. And then we're in the situation to say that, basically we lose our credibility, you lose your credibility. So, if you want that certificate to have any kind of value, you have to really prove something. So, So in case you have trouble with the project in the end, you can use this as, let's say, as leverage, or go a bit through some of the other assignments that you did so far and kind of show, like, okay, look, I kind of proven this or that. I understand most of you don't have a lot of free time, but, you have to show something. So that's about what it's until next time. And 2 weeks from now, prepare the one slider about your group project. Send it to me at least 2 days before that lecture, because I would then put them in the presentation, and then I can just click next, and then you can talk. So one of you, or multiple of you in the same team, you'll have to explain it in 2 minutes or 3. Okay, maximum 5 is something really great, but yeah, ideally 2-3 minutes. You have to say in certain sentences, what is your project about? What's its impact on society, or what's the business case? How does it make money, or how does it make humanity better? In some way. And then a few words on the technology and the libraries that you would use. You might say stuff like, we're going to use a web server, and we're going to have a database with multiple collections, and then like kind of explaining pretty much like why is it technically possible or not. So you'll get this actual link to that spreadsheet. And this is pretty much about the planning. Any questions about this? What you have to do? Or certificates or anything else, the course? It's the last minute, so. Nothing? Everything is very clear, I guess?
Should we discuss ideas on Slack, see what people want to join, or?
Yeah, that would be really great, honestly, like to have this kind of environment. And keep in mind, like all these people that here are in this group, like it's nice to interact with each other, because especially if you actually want to get in this field, to get a career in this field, it's important to keep a network. And you never know what you can learn from one of your peers. So throw ideas on Slack. If you have a group and you're confident of the idea that you want to make, type give me a message and let's have a video call to kind of like say that, okay, this is possible to do, and so on. So for every group, we can have a small group call every time you defined your idea and so on in your group. Okay, in general, we're out of time, so this is pretty much it for today. I'm still going to be here for a minute if you still have questions about any of the slides. As usual, code will be on GitHub. We'll put the link, video and PDFs and all that kind of stuff you already know. So if you do not have any more questions, I wish you a nice evening. Otherwise, I'm here for another minute.